Today we will start and finish lesson 2. Our lesson is about acceleration. It is closely related to velocity. I will remind you of velocity in order to be able to go through this lesson. The objectives mainly are to define acceleration, to know the units, to calculate the average acceleration, to identify when do we have acceleration, and to predict the outcome of velocity and acceleration changes, whether they are in the same direction or opposite direction. How can we describe them? Now let's review velocity. Velocity depends on speed and direction. These two cars are moving in the same direction, but do they have the same velocity? No, since the black car is ahead of the white car, so they have different speeds. Since they have different speeds, even if they have the same direction, they have different velocity. The red cars, both of them, they are moving at the same speed, 25 meters per second, but they are in opposite directions. So, of course, they have different velocities. The car is taking a turn. Even if it's moving at the same speed, but it's changing direction, it means that it is changing velocity. What is acceleration by definition? Acceleration is the rate at which velocity changes. In other words, acceleration describes how fast a moving object can change speed, direction, or both, which means velocity. Usually, acceleration is mistaken for the term speeding up. You will see later that acceleration can mean also slowing down. Just wait for the coming slides. How is average acceleration calculated? We should not forget that acceleration is the change in a velocity in a certain period of time. That's why acceleration is the change in velocity is described as final velocity minus starting velocity, or final velocity minus initial velocity over time, or acceleration equals to v2 minus v1 over time. Sometimes you have it in some books as a equals acceleration equals vf minus vi, yani velocity final minus velocity initial. Now it's time for application. I want you to prepare your copybook, write the title, acceleration, and the date. I want you to copy every question and keep a calculator next to you. Please try to stop the PowerPoint to put your answer before you receive it from me, because I want you to act as if we are doing it in the classroom. I will start with the first question. I want you to look at the cyclist. Does the cyclist have a constant velocity throughout his trip? I mean, at position A, B, C, and D, does he have a constant velocity? In fact, he has the same direction, but the speed is different. It was changing from 4 meters per second to 8 meters per second and then to 7. So, no, it is not a constant velocity. Question 2. Indicate the initial velocity. Initial means the first velocity at the beginning of the experiment. I want you to look at the four positions, A, B, C, and D. Which one is the initial position or velocity? It's at A. So what is the velocity? It is 4 meters per second. Don't mention the time. Indicate the final velocity. So the final velocity, it is the one at position D, which is 7 meters per second. Now I want you to continue questions 4, 5, and 6, but I have put them on different slides. Question 4 now. Does the cyclist change his velocity from point B to point C or from position B to position C? Please look at these positions down, B and C. What do you notice about the direction? Does it differ? No. What about the speed? It's the same. So what is the acceleration then? I want you to solve it. V1, we will take it given V1, it is at position B, it is 8 meters per second. V2, it is the final velocity, also 8 meters per second. If you look at the time, at B it was 1 second, at C it is 2 seconds, so the time needed to reach C is 1 second. What is the acceleration? We put the formula, acceleration equals V2 minus V1 over time. In other words, it is V initial final minus V initial over time. We substitute 8 meters per second minus 8 meters per second over 1 second. 8 minus 8, 0. 0, you divide by any number, it will give 0 meters per second. So what is the acceleration? Do we have any acceleration here? No, because if you notice that the cyclist from point B to C, he is moving with the same speed and same direction. It means the same velocity. There is no change in velocity. Don't forget that acceleration is a change in velocity over time or within a given time. No change in velocity, I mean speed or direction or both, it means no change in acceleration. Now let's move to question 5. Now we will start with number 5. Calculate the average acceleration of the cyclist between points A and B. I want you to put on your copybook, put the given and the formula. Look at a point A, write V1. What is V1? B, at B, write V2. What is the velocity? The time, it was 0 seconds, it became 1 second. It means that it took 1 second in order to cover the distance. And we are asked to find the acceleration. Put the formula. A equals V2 minus V1 over time. I want you to substitute each one by its value. Don't forget the units. So acceleration is 8 meters per second minus 4 meters per second over 1 second. So it will be 4 meters per second over 1 second per second. Usually we say it meters per second squared. So what does this mean? We will explain by it. We will explain it later. It means that in every second the cyclist is increasing its velocity or changing its velocity by 4 meters per second. Now we reached question 6. Also, please write 6, you copy the question, and you solve, please. Question says, calculate the average acceleration of the cyclist between points A and D. The same, I want you to put the given. V1, it is at position A, 4 meters per second. V2, it is at D, 7 meters per second. And the time needed from 0 to 3, it means it's 3 seconds, the time needed to change this velocity. Put the formula, acceleration equals V2 minus V1. Substitute numbers with the correct units in the numerator and denominator. So we will get 7 minus 4 meters per second, it is 3 meters per second over 3 seconds. 3 by 3, 1 meters per second over second means meters per second per second. We express it by meters per second squared. So this cyclist, it's changing his velocity each second by 1 meters per second. But don't forget, this is the average accelerations. In other words, the velocity was not changing exactly as 1 meters per second every second. Now I want you to understand what do we mean by the unit of acceleration. What does it mean? It means that the cyclist throughout the trip was moving at 1 meters per second or 1 meters per second squared. I have put it into different boxes, red and blue, to explain for you. First, I'm going to start with the red circle. It means per second, it means each second in 1 second. In other words, each second the cyclist increased his velocity by 1 meter per second. In other words, the velocity was changing 1 meters per second every second. How can accelerating objects change velocity? Look at this diagram, I have put it for you. Usually, objects can change acceleration because they are speeding up or slowing down or changing direction. How can accelerating objects change velocity? Like velocity, acceleration is represented by a vector which has magnitude and direction, amount and sense in a special direction. Accelerating objects can change speed. So a person moving in the picture on the left, you can see that he's speeding up. It is represented by a vector that is getting longer. Since he is speeding up, we call it positive acceleration. While as if you look at the picture to the right, the person is slowing down. This is represented by the vector, accelerating vector. It's getting shorter. So he is slowing down. And we call this acceleration negative acceleration. It is, in other words, they call it deceleration. So acceleration is not speeding up the whole time. It can be slowing down as well. How do we represent positive and negative acceleration? You will see later that we can represent negative acceleration by a negative sign. You will see it later. How can accelerating objects now change velocity? Now we will start application again. Application 2, prepare your copybooks. Copy the question, please, and you solve. A cyclist was pedaling at a velocity of 2 meters per second west. After 3 seconds, he could reach a velocity of 5 meters per second in the same direction. Calculate the average acceleration of the cyclist. So, initial velocity, or V1, is 2 meters per second, V2 is 5 meters per second, and the time is 3 seconds. I want you to tell me, which one is greater, initial velocity or final velocity? Final velocity. So do you expect that you have positive acceleration or negative acceleration? Positive acceleration. Solve, please. So it is V1 2 meters per second, V2 5 meters per second, time 3 seconds. You apply the formula V2 minus V1. You substitute correct answer with the correct unit, and the answer will be 1 meters per second per second. In other words, each second the cyclist is increasing the speed by 1 meter per second. So the cyclist was accelerating 1 meters per second each second, so the acceleration is positive acceleration. Now we will start with application 3. Also, please copy the question and solve. You put the given and the formula if you please. If you want to work properly, this is what should be done. You have a car that was moving down the road at 15 meters per second, and then the driver notices a stop sign ahead of him. So he applied the brakes and comes to a stop in 5 seconds. What do we mean by stop here? So, what is the velocity at when he stops? It is 0 meters per second. So, he started at 15 meters per second, and the final velocity was 0 meters per second. In 5 seconds, he could bring the car into total stop. What is the average acceleration of the car when the brakes are applied and the car stopped? So V1 is 15 meters per second, initial velocity. Final velocity is 0 meters per second because it stopped. It took 5 seconds in order to come to a final stop, and the acceleration is V2 minus V1 over time. You substitute the correct number and the correct unit. So it is V2 minus V1. You substitute. V final is 0 meters per second minus 50 meters per second over 5 seconds. Look here, I have done a mistake. By mistake, I typed SS. It is just seconds. Now, 0 minus 15, it is negative 15 meters per second over 5 seconds. Negative 15 over 5, it is negative 3 meters per second, or negative 3 meters per second squared. What does the negative mean? Negative acceleration, because the car was slowing down rather than speeding up. So we say that the car was decelerating 3 meters per second each second, or it was going into negative acceleration.